Hello friends, how are you? Today we are starting a new chapter which is Introduction to Fixed Income Valuation. Let's say there is a bond which is maturing in 5 years. Now, initially the bond was issued at $100, let's say, which was 100% of par. Its coupon was 5%, that is $5 every period, right? And at maturity it is supposed to pay back the $100 plus the final coupon amount. Now at t is equal to 2, we want to find the value of the bond. Value of the bond means with respect to the market discounting rate, that is whatever the required rate of return the market is asking for, what is the value, the present value of the bond at t is equal to 2. Let's say the market discount rate or the required rate of return by the investors is the same thing. Right now, for simplicity, we will consider this is the required return for the investors. This is at t is equal to 2, this value is 6%. And we are also assuming that from t is equal to 2 till t is equal to 5, this asking rate or required rate is going to be the same. So what is going to be the value at t is equal to 2? Let's find out. So I write 2, 3, 4, 5. Now I am trying to find the value here, right? So the coupons that I will be receiving is 5 here, 5 here, 5 here, and the maturity amount if I keep it till maturity, right? And the discounting rates at this point is 6%. Discounting rate at this point is also 6%. Here also it is 6%. Therefore, to find the present value, we just have to consider each of these cash flows as if they are zero coupon bonds with their maturities at t is equal to 2, the distance of their maturity being the distance from t is equal to 2 to their position. So this will mature in 1 period, this will mature in 2 periods, right? And this one will mature in 3 periods, right? So it's easy now to find out the present value, right? PV will be sum of all these 3 individual cash flows. This will be 5 divided by discount rate to the power the maturity, that is 1 period. Here there are 2 steps to be taken, so 1.06 to the power 2 plus 105 divided by 1.06 to the power 3. Let's take out the calculators and find the value out. Now this, using your calculator, you can also find it in this way. The payment, the periodic payment, you can take as 5. The future value, that is the maturity payment, you can take as 100. The number of periods is 1, 2, 3. So n is equal to 3. Yield, that is the asking rate or the required rate, is 6. And we need to find out what is the PV, right? This we need to find out. So with the calci, we just enter these values: 5 in place of PMT, 100 as FV, 3 as N, 6 as required return or I/Y, and we compute PV. This turns out to be, the PV turns out to be 97.3269. So this is the present value of the bond given the conditions we have assumed, right? That is, we are assuming a required rate of 6% from t is equal to 2, and there are 3 coupons and 1 maturity amount to be received at certain periods of time. We reduce them to the present values and sum them up, the individual cash flows, we reduce them to the present values and sum them up, and this is the value we get. Now one thing you can observe here is that this bond right now is trading below par, right? It is trading below 100% of par, because 100% of par was 100 and this is 97.3269. So it is not up to the par value, right? So we say this is trading at a discount. This bond is trading at a discount. Instead of using these values PMT, FV, N, I/Y, you can also do it directly by dividing 5 by this number, another 5 by this number, 105 by this value, and get the same value. You can cross check it. Now we will take another angle of deducing this present value. That is the angle of measuring the present value of the deficiencies. Let's look at what we are talking about. So our assumptions were the coupon is $5. The maturity amount is 100. The number of periods remaining when we are calculating the present value was 3, and the required return was 6. The present value turned out to be 97.3269. This was the present value, right? So this was our calculation. Now here, if we have to take the deficiency angle, what do we mean by that? Now here, if we have to take the angle of deficiency, what do we mean by that? Deficiency is basically the coupon minus the required return. In this case, it is $5 minus $6, because the required return is 6%, right? So it is minus $1 per period in terms of deficiency of the coupon. So the present value will be present value of deficiency. This will be minus 1 divided by 1.06 to the power 1 plus minus 1 divided by 1.06 to the power 2. Here also minus 1 divided by 1.06 to the power 3. The maturity amount is 100, so there is no deficiency in those terms. We just have to calculate these, the summation of these individual terms. Let us do that. Minus 1 is the PMT. Maturity is 3 years. Yield or required return is 6. Future value is 0. We just need to find out the present value. This comes to be 2.673. There will be a negative sign. Now the par value was 100, right? Let's do par minus total of deficiency. Now if we adjust this deficiency from the par value, that is 100 minus 2.673, we get 97.3269, right? And this is exactly the value that we got from calculating the present value of the bond. So this is just another way of finding out the value of the bond, this time from the root of deficiency. Now let us take another example. Let us say again maturity of a bond is 5 years. The initial issue was at 100% of par, which was $100, let's say, and the coupon was $8, right? So $8 coupons for 5 periods plus the maturity amount. The required return, that is the market discount rate or the required return, here is 5%. What will be the present value of this bond? This time we are calculating the present value at t is equal to 0, right? Present value is equal to, again we will take each of these cash flows like they are 0 coupon bonds, right? And we will just find out their present values, individual present values at this point, right? This point, like this. This is 1 periods, this is 2 periods, this is 3 periods, this is 4 periods, this is 5 periods. So we just find out the present value by summing up their individual discounted present values, and discounted by what? The market discount rate or the 5%. So let us do it. 8 by 1.05 to the power 1, the first one. Second one will be 8 by 1.05 to the power 2, then 1.05 to the power 3, 1.05 to the power 4, 108 by 1.05 to the power 5. We can easily find out the value, friends. 5 is the required rate, periodic payment is 8, maturity amount is 100, number of periods is 5, the present value comes to be 112.988. This again we can calculate it from a different angle, from the angle of excess. So here previously we had found a deficiency of -1, right? Here if we do the same thing, what will be the answer? It will be 8 minus 5, this will be plus 3, right? So from the angle of excess, the present value of the excess is 3 divided by 1.05 to the power 1 plus 3 divided by 1.05 to the power 2 plus 3 divided by 1.05 to the power 3 plus to the power 4 plus to the power 5. This will add up to, we take 3 as the periodic payment, 5 as the maturity period, required return as 5. The present value comes to be 12.988. Okay. So if we adjust the par with the excess, what do we get? We get 100 plus 12.988. This is 112.988. So this bond is trading at a premium, and we have deduced their values from two angles: angle of the present value calculation of the bond and also from the angle of excess, that is the present value of the excess. So 112.988 is the value that we got from this calculation, and here also we got the same value. So from these calculations and examples, what we can understand is bond price has an inverse relation to the required return or market discount rate. This is postulate number 1. Now let us go to the second postulate. Let's say there is a bond which matures in 5 years. The bond is issued at 100% of par. It has a coupon of 10%, that is $10. Now initially the market discount rate was 7%. So in this case, what will be the present value, friends? So we can calculate it this way. Number of periods is 5, periodic payment is 10, maturity amount is 100, the required return is 7, the computed present value comes to be 112.3. 112.3. Now let's say there is a case 1 where this market discount rate increases to 8%. Case 1, market discount rate increases to 8%. What will be the present value here, friends? We just change the required return to 8% and compute the present value. This comes to be 107.985. We take another case, case 2, where the market discount rate decreases from 7 to 6%. Here what will be the present value, friends? Let's again calculate. We just change the required return to 6 and compute the present value. This comes to be 116.849. Now if we measure the change from the base case to case 1 and case 2, let us make an observation out of it. 116.849 minus 112.3, this gives 4.549, and 112.3 minus 107.985, this gives 4.315. So can you see the difference, friends? This is larger, right? From here we can draw the second postulate, which is for the same coupon and maturity amount, decrement of the market discount rate has more positive impact than the negative impact of an equal increase of the market discount rate. So this is postulate number 2, friends. For same maturity and coupon rate, fall in market discount rate has a larger positive impact on the price of a bond than the negative impact on the price of a bond when an identical amount of rise in market discount rate happens. So let's say a market discount rate rises by 1%. This will have, say, a price decrement of del P, and if the rate falls by 1%, this will increase the price by del P prime, let's say. This postulate is saying del P prime, the magnitude of del P prime will be greater than the magnitude of del P. This is also called the convexity effect. Now let us come to the third postulate through an example. Let's say again a bond has a maturity of 3 years. It has a coupon of 2% and it's issued at 100% of par, right? The market discount rate is 5%. This is bond 1, right? There is another bond, bond 2, which is a coupon of 8%. Now a scenario happens where this market discount rate changes from 5 to 4%. Now we have to find out what was the value of these two bonds when the rates were 5% and what came to be the value of these two bonds when the rates became 4%. Let us do that. So PV at market discount rate is equal to 5. This will be, let us calculate. Time to maturity is 3, maturity amount is 100, required return is 5, coupon payment is 2, present value comes to be 91.830. Now we find out the present value when the market discount rate is 4%. This comes to be 94.449. So the difference is 94.449 minus 91.830. This is 2.619. This is the difference. Now we find out the same present values for bond 2, B2. PV at market discount rate equal to 5 is given by 100 is the maturing amount, 3 is the number of periods, 8 is the coupon, 5 is the required rate. Present value becomes 108.169. 108.169. Now, what is the present value when the required rate or the market discount rate is 4%? MDR is equal to 4. This comes to be 111.1. Now, here the difference comes to be 111.1 minus 108.169. This is 2.93. Now, if we try to calculate the percentage change of the price, this will be 2.619 by 91.830. This will come to be 2.619 divided by 91.830. This comes to be 2.852%. And if we calculate the percentage change of price for bond 2, this will come to be 2.93 divided by 108.169. This will come to be 2.93 divided by 108.169. This is 2.708%. So, if you compare these two percentages, this one with this one, you will see percentage change of bond 1 is greater than percentage change of price for bond 2. This is our second postulate. For the same change in market discount rate, the percentage change in price of a lower coupon bond is higher than that of a higher coupon bond. Again, I will repeat, for the same amount of change in market discount rate, the lower coupon bonds price change percentage will be larger than the price change percentage of a higher coupon bond. And this, we are assuming that the maturity is constant. This is postulate number 3. For the same time to maturity, the percentage price change of a lower coupon bond will be higher than the percentage price change of a higher coupon bond when the market discount rate changes by the same amount for both from an initial identical amount. Now, we will look at the fourth postulate. This one, by the way, is called the coupon effect. Let's say there is a bond B1 whose maturity is 3 years, and there is a bond B2 whose maturity is 5 years. Both have a coupon of 8% and they are issued at 100% of par at t is equal to 0. Now, the initial market discount rate for both of them is 5%. Let us find out the present value of B1 and B2 under these conditions. Present value of B1 for market discount rate of 5%. This will be, we take 100 as the maturity amount, 3 as the number of periods to maturity, 8 as the periodic payment, 5 as the required return or the market discount rate. The computed present value turns out to be 108.169. Similarly, for bond B2, the present value under similar conditions, that is market discount rate of 5, will be equal to 112.988. Now, we consider that the market discount rate changes from 5% to 4%. And under these conditions, we have to find out what is the present value of each of these bonds. So PV of bond 1 for a market discount rate of 4% is equal to 111.1, and for bond 2 under similar circumstances the price turns out to be 117.8, to be precise 117.807. Now if we try to take out the differences, the percentage price change, see what happens. So percentage price change for B1 is equal to 111.1 minus 108.169 divided by 108.169, which is the initial value. This will be equal to, let's find out, 111.1 minus 108.169. This is equal to 2.931 divided by 108.169. This is 2.709%. And the percentage price change for bond B2, let's find out. Percentage price change for bond B2, this will be 117.807 minus 112.988 divided by the initial value, which is 112.988. This turns out to be 4.26%. So you can see here also, friends, there is one phenomenon happening. Percentage price change for B2 is greater than percentage price change for B1. So here comes our fourth postulate, that is, for the same coupon rate, the bond with the higher maturity generally has a higher percentage price change for the same amount of change in market discount rate. So generally, for the same coupon rate, the bond with the higher maturity exhibits higher percentage price change for the same amount of change in market discount rate. This is our postulate 4, and this is also called the maturity effect. Valuation through the use of spot rates. Friends, let's say a bond has a maturity of 3 years. Now, in reality, like any other rates which can fluctuate, the interest rates do fluctuate with time. So let's say at time t is equal to 1, the rate is 4%. That is the required rate. At time t is equal to 2, the rate is 5%. At time t is equal to 3, the rate is 3%. Now, how do we calculate the present value when the rates are changing like this? It's very simple, my friends. Let's say we have a bond which has a principal of $1,000 and a coupon of 10%. So which means $100, right? So here it is 100, and in the third case also it is going to be 100 plus the maturity amount. So here, to find the present value, here what we do is we discount these individual values with the respective spot rates, right? Here, all that we do is discount these individual values with the respective rates that are prevalent at the respective times. And these rates, my friends, is called the spot rate. These rates are called the spot rates. And these rates, my friends, are called the spot rates. These are the spot rates because at the prevalent time, they are the rates that are available in the market. So we perform the calculations, friends. This is going to be 100 divided by 0.4. This is 100 divided by 1.05 square, because we are going to go 2 times to get the present value at t is equal to 0. Here again 1100 divided by 1.03 cube, because we'll be going 3 times to reach t is equal to 0, right? So the calculation comes to be 100 divided by 1.04, this is equal to 96.15 plus 100 divided by 1.05 square, this comes to be 90.70. This is 1100 divided by 1.03 cube. 1100 divided by 1.03 cube. This is 1006.65. Okay. Now the addition comes to be 1193.5. This is the present value at time is equal to 0. So this is how we value a bond with respect to spot rates. It's very similar to what we did in the previous cases also. Only thing is, instead of a constant yield to maturity, we are taking the individual spot rates at the respective times. So friends, now we want to understand, we have previously valued a bond at a specific beginning of a period, say t is equal to 2, t is equal to 1, t is equal to 3, or t is equal to 0. Now we want to value the bond at any interim period. That is, it does not necessarily have to be at the beginning of a period. How do we do that? Valuation of a bond at any time t. We will have a look at this here. Now to look at this, we'll encounter 3 new terms, which is full price of a bond, flat price of a bond, and accrued interest. And these 3 together will fulfill our valuation targets. Let's say there is a bond with a maturity of 3 years and semi-annual coupons, and the annualized coupon rate is 10%. Okay? Let's first draw the timeline. And we are going to draw the timeline with respect to the coupon payment dates or the times. So at 6 months there will be a payment, at 1 year there will be a payment, at 1.5 years there will be a payment, at 2 again, 2.5, and the final payment will be at 3. So let's say the initial principal was $100. Now at 0.5 there will be a payment of 10% by 2, which is 10 by 2, that is 5. Again at 1 there will be a payment of 5. Again here there will be a payment of 5, 5, 5. Here the maturity amount along with the interest is going to be paid. Now let's say we are looking to value this bond at some time which is 1 year 3 months. So 1 year has passed and plus another 3 months has passed. So 1.25. This is the time where we want to value, right? How do we value it? Now to value this, we have to first understand something called the accrued interest. Let's understand it. Accrued interest is basically the proportion of the interest that is pending at any interim. Now the accrued interest is basically the interest payment which is pending at any interim time between 2 consecutive interest payments. So let's say here one interest payment was due, it has already been paid. Here again there is another interest payment which is due, but this is yet to be paid, right? So at this point, this interest is already paid, so it is out of our contention, but this, some proportion of this is within our contention. How much of it? It is basically this total period, that is the time period between two interest payments, let us call it T, and this period, let us call it small t. So the accrued interest will be calculated as the small t by the big T into the interim coupon payment, right? This is basically the accrued interest. So let us define it. Accrued interest is the proportion of the unpaid interest that is due based on the interim time period on which we are calculating the accrued interest. Accrued interest is the proportionate pending interest with respect to the ratio of the time at which we are calculating the accrued interest and the total time period between two consecutive interest payments. So here we have calculated the accrued interest by taking into account the periodic payment of coupon, right? The periodic payment of coupon, the time small t, which is the time from the last interest payment, and the time caps t, which is the total time period between two consecutive interest payments. So this is how we calculate the accrued interest. Now what is the role of this accrued interest in the calculation of the present value of our bond at any time t? Let's see that. Now the full price, that is the PV full of a bond at time t, is equal to the flat price or the clean price of the bond plus the accrued interest at time t. This is basically the relationship which holds when we are trying to find an interim period valuation of a bond. Now let us deduce the PV full at time t. Now we had already gone through this timeline. We are trying to value our bond at time t, which is 3 months from the payment of interest at t is equal to 1, right? So this is the payment of interest at t is equal to 1. We are looking to value the bond at t is equal to 1.25 or 3 months from the 1 year interest payment. Now if we were to value the bond at t is equal to 1, how would we do that, friends? PV at t is equal to 1, when the interest has already been paid, the value would be, this is equal to PMT by 1 plus required rate by 2 to the power 1. So we take this one into account. Here PMT is 5. Now we take this one into account. 5 by 1 plus R by 2 to the power 2. Why we are doing R by 2? Because it's a semi-annual payment, right? This is a semi-annual period. This is half the period. Again, this is half the period. So whatever required rate, this R is equal to annualized required rate. So to get the periodic required rate, we have to divide it by 2. So R periodic is equal to R by 2. So now we take into account this one. This one will be 5 by 1 plus R by 2 cube, and the last one will be this one. This is 4 periods, right? 1, 2, 3, and the last one is 4. So this will be 105 by 1 plus R by 2 to the power 4. Okay. So here The periodicity is semi-annual. The coupon is being paid semi-annually. That is, the periodicity is 2. Instead of it being semi-annual, it could be quarterly or monthly or annually. So instead of 2, we write M. M periods in each of the annualized coupons. The coupon here is 5, but it could be any other payment. So the periodic payment here is 5, but it could be any other payment, right? So it is basically the annual coupon divided by the periodicity, right? So we write PMT by M. In total, the number of periods here is 4. This is equal to the number of years which is left, that is 2, into the periodicity, which is 2 again, right? So in this 2, that is the number of years left to maturity, we write N. Here, instead of this 2, we write M. So we rewrite the entire expression once again. PV full is equal to PMT by M divided by 1 plus R by M 1 minus T by T plus PMT by M by 1 plus R by M 2 minus T by T plus dot 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 dot. The last payment will be principal plus PMT by M divided by 1 plus R by M to the power N into M minus T by T. This is the entire expression. Now here, this can be rewritten as PMT by M divided by 1 plus R by M to the power 1 plus PMT by M 1 plus R by M to the power 2 plus up till principal amount plus PMT by M divided by 1 plus R by M to the power number of annual periods into the number of periodicity, total multiplied by 1 plus R by M to the power T by T. Because this was in every of this term, we have this one common, right? 1 by 1 plus R by M to the power minus T by T. If we just invert this, this becomes 1 plus R by M to the power T by T. We have just infused this one here. So this is PV full. Now this entire expression within the brackets we write as PV dashed. PV dashed into 1 plus R by M to the power T by T. Also we know what is accrued interest, right? Accrued interest is equal to T by T into PMT by M, right? The periodic interest payment here, previously we used the periodic interest payment only was expressed as PMT. Here we are expressing the same thing as PMT by M, that is the number of periods. PMT is basically the annual coupon rate. So we can deduce the formula for PV flat as PV full minus AI. This is our final expression of a clean price of a bond and a full price of a bond. Now let us do an example based on this, guys. Let's say a bond has a periodicity of quarters, right? Quarterly coupon payment. Annualized coupon rate is 8%. Maturity is 4 years. Required return is 6%, let's say. This is the annualized one, right? Let's say a quarter means 90 days. We are valuing this bond at 1 year and half of a quarter, that is 1 year and 45 days, right? So we have to find the PV flat at T is equal to 1 year and 45 days. Let's do it. 1, 2, 3, 4. 0, 1, 2, 3, 4. This is our entire maturity period of the bond. We are trying to find out the value of the bond at certain time, which is here, right? 1 year, 45 days. Now, if the annualized coupon is 8% and the initial principal is 100, so the total annual payment is 8, which means between 1 and 2 there has to be 4 payments of $2. So here if I divide this period into 4, 1, 2, 3 and 4, the payment will be 2 here, 2 here, 2 here and 2 here, right? Now we zoom into this segment, this first segment. So T is equal to 1 and T is equal to 1.25, that is the first quarter. Here the payment is 2. Now our valuation is happening here, right? T is equal to 1 year and 45 days, which actually means 1.125. Right? So we easily calculate our accrued interest. Accrued interest at T is equal to 45 by 90 into 8 by 4, or which is 8 by 4 is 2. So this comes to be half into 2 is equal to $1. This is our accrued interest. We hold it for some time. Now we find out the full price of the bond. PV full is equal to, how many periods are we looking at, guys? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 periods. That is M into N is equal to 12. and T by T we already know is equal to 0.5. So we just put in the values here. Here PMT by M by 1 plus R by M to the power 1 plus PMT by M by 1 plus R by M to the power 2 plus PMT by M divided by 1 plus R by M to the power 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, right? Into 1 plus R by M to the power T by T, which is 0.5, principal amount plus PMT by M divided by 1 plus R by M to the power the number of periods which we counted as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 into 1 plus R by M to the power T by T, which is 0.5. Now we can put in the values here. PMT by M is 8 by 4, that is 2. R by M is equal to 6 by 4, which is equal to 1.5% or 0.015. So this becomes 1.015 to the power 1 plus 2 by 1.015 to the power 2 plus plus 102 by 1.015 to the power 12, this into 1.015 to the power 0.5. This entire value, this one, we can calculate it with our financial calculator in this way. Future value is 100, periodic payment is 2, required return is 1.5, number of periods is 12. We need to find out the present value or the PV dashed. So this becomes 2 is the PMT, 100 is the FV, 12N, 1.5 is the required return. We can compute PV. This comes to be 105.45 into 1.015 to the power 0.5. This is equal to 106.24. Therefore, our PV full is 106.24 and our accrued interest was $1, right? Therefore, our clean price or PV flat is equal to 106.24 minus 1 is equal to 105.24. So this is our final calculation, guys. Matrix pricing. Matrix pricing is basically a method that is used to figure out the correct or the valid price for a bond which is not traded that frequently. Let's look at through an example how this is done. Let's say there is an information available of 2 actively traded 2-year bonds. One with a coupon rate of 4%, another with a coupon rate of 6%. And there is also information available for a 4-year bond, in fact 2 4-year bonds, again one with a coupon rate of 4%, another with a coupon rate of 6%. Let's say this one is trading at a price of 98. This one is trading at a price of 99. This one is trading at a price of 100. This one is trading at a price of 102. Now we have to find the price or the present value, the valid present value of a 3-year bond with a 5% coupon. This is what we have to find out. Now how do we do that? We do it stepwise. Step 1, average yields. Now we find out the yields of this bond and this bond and take out their average. How do we do that? Easy. Now for this one, we take number of periods as 2, future value at par or 100, present value at 98, periodic payment as 4, and we just need to find out the yield, right? We can easily do that. PV is equal to minus 98, FV is 100, PMT is 4, N is 2, we compute the yield. This comes to be, for the 2-year set of bonds, it comes to be, the first one is giving 5.076%. Okay. Now the next one will be, now for this one, N is equal to 2, FV again is 100, PV is minus 99, PMT is 6, we need to find out the yield. The yield is coming to be 6.5496 or approximately 6.55. So we take the average of these two, 6.5496 divided by 2. This comes as 5.8128. Similarly, for these two also we calculate the yields. For this one, N is 4, FV is 100, PV is minus 102, PMT is 6, we need to find out the yield. For the 4-year bonds, the first yield that we have calculated is coming as 5.4303. Now we find out the same for this one. N is equal to 4, PMT is equal to 4, FV is equal to 100, PV is equal to minus 100. So the yield we can calculate, this is coming as 4%. So here it is coming as 4%. So we take an average of these two, it comes to be 4.7151. Now what do? We go to step 2, which is finding the weight of yield for longer duration bond, that is the 4-year bond. Now there is a formula for this. This weight is counted as M minus S by L minus S. M is the target, that is our 3-year bond. S is the 2-year bond. L is the 4-year bond. So this weight value becomes 3 minus 2 by 4 minus 2. This is equal to half. So the yield of the 3-year bond, is equal to half of the yield of the longer duration bond, that is the 4-year bond, plus 1 minus the weight of the longer duration bond into the yield of the shorter duration bond. This is equal to half into 4.7151 plus 1 minus half is half into 5.8128. This gives us 5.2639%. Now if we have to calculate the present value, that is the price of this bond, how do we do that? We have period, which is 3 years. We have the coupon, that is the periodic payment. This is 5, right? See, here the coupon payment is 5. Future value is at par or 100. Yield is 5.2639. We need to find out the present value. Can't we do that? Yes, easily we can do that. This comes to be 99.2846. So we put the value in the matrix. The value is 99.2846. This is our desired answer. Guys, one thing we can modify just a little bit here. It's always best to take 4 points after the decimal. So in this case, the yield becomes 5.0767 instead of only 5.076, and the average yield changes to 5.8131. If we take this value and calculate the final yield, so here this one becomes 5.8131 instead of 5.8138, right? 8131. Therefore, the average becomes 5.2641. So instead of 5.2639, we make a little change here, 5.2641. Now this value of the bond now will become, the present value comes to be 99.284267. Now a few terms that are being introduced we must get acquainted with. One is a street convention yield. This is basically the yield that is expressed without considering the weekends and holidays in a year. Then there is the true yield. This one does consider these weekends and holidays. There is something called the benchmark, friends. Let's say for a mutual fund in India, the benchmark can be the Nifty. Nifty is the stock index, right? So its performance is compared with the performance of the Nifty. Now while for equities, the benchmark can be a Nifty for India, or it can be the Sensex, right? Or for US equity, it can be the Dow Jones. But for a fixed income, it can be something like the government bond yield curve. It can be the government bond returns and its volatility. So, comparative basis. Now let's say a government bond can be yielding 4% and the corporate bond can be yielding 6%. It has the similar qualities like the similar tenor, similar kind of coupon rates, but this is a difference. Now this spread is called spread from the benchmark. provided this government bond is being used as a benchmark for this, right? This government bond is used to compare the performance of the corporate bond. In that case, this difference of yield will be called the spread from the benchmark. Now let's say this difference is for a 5-year bond, right? Now we plot the timeline on the horizontal axis. This is 1 year, this is 5 year, this is 10 year, this is 20 year, this is 30 year, right? I'm just compressing the horizontal timeline, and here we plot just this difference, this spread. So for the 5 year it is 2, 1, 2, 3, 4, 5, 6. So for the 5 year it is 2. Let's say for the 10 year it is 4. For the 30 year it is 6, right? Now let's say for the 1 year it is 1. Now if we can draw a curve here like this, this curve will be called the term structure of spread. Term structure of spread over benchmark. Annualized yields for varying compounding periodicities. Let's see what we mean by this. Let's say there is a bond B1. It pays coupon semi-annually. Let's say its maturity is 4 years. Coupon percentage, let's say, is 10%. Future value is at par, which is 100. Presently, it is trading at 101. Now we need to find out what is the yield of this bond. Now if it is paying coupon semi-annually, we can say periodicity or m is equal to 2. Therefore, the number of periods is 4 into 2, which is 8, and the periodic payments is 10 by 2, right, which is equal to 5. Future value is 100, present value is by convention minus 101. So we can easily find out the required return, right? This will be equal to 4.8462. But this is the semi-annual half-yearly yield. To annualize it, we have to multiply it by 2. This is equal to 9.6924. 9.6925 approximately. Okay, so this is coming to be 9.6925. Now let's say instead of being compounded semi-annually, this bond was compounding quarterly. Then what will be the annualized yield? So semi-annual yield we'll give by Y2, and the quarterly yield. Now what if this bond, instead of being compounded semi-annually, was compounded quarterly? Then what will be the annualized yield? Now there is an expression for that. It goes like this: 1 plus ym by m to the power m is equal to 1 plus yn by n to the power n, where m and n are periodicities for otherwise identical bonds. Now let us put up the values here. Now this will translate as 1 plus y2 by 2 square is equal to 1 plus y4 by 4 to the power 4. Now this is the annualized yield for the case where it is semi-annually compounded. Y4 is for the quarterly compounded case, right? Again, I'll repeat, Y2 and Y4 are annualized yields for semi-annual compounding and quarterly compounding respectively. These are not the periodic yields, these are the annualized yields for semi-annual compounding and quarterly compounding. So this implies 1 plus 0.096925 by 2 square is equal to 1 plus y4 by 4 to the power 4. This basically means this value, this periodic value. So we just use this 1.048462 square is equal to 1 plus y4 by 4 to the power 4. This implies 1 plus y4 by 4 is equal to 1.099273. We just invert this to the power 4 to 1 by 4 here. Easily we can calculate it. So this is equal to 1.023944. Therefore, y4 becomes 1.023944 minus 1 into 4. This is equal to 0.095777 or 9.5777%. This is our annualized yield when the compounding is quarterly. Now we can also find out what is the annualized yield when the compounding is yearly. How do we do that? 1 plus y2 by 2 square is equal to 1 plus y1 by 1 to the power 1, implying we can take the value from here. 1 plus y1 by 1 is equal to 1.099273, implying y1 is equal to 9.9273%. So when the compounding is annual, the yield comes to be this 9.9273. This is also called the effective annual rate.